All right, welcome folks. I see people are coming into the webinar. So as we get people joining, I just want to say thank you for taking the time to join us here today. Today we are going to be talking about some microgrid development solutions and kind of getting into this movement into the microgrid, adding microgrids or storage into this microgrids as moving away from just straight solar projects. So again, appreciate you taking the time to join us here today. As we get going, for those of you that maybe haven't joined us on a previous Ask Mayfield Anything, we are very much wanting this to be interactive. And so there's the Q&A function on the Zoom call, and you are welcome to submit your questions. We like to see what people are asking. We do have a poll here just to kind of get a sense of where people are sitting and what they're looking for from this today. So if you have a moment to answer that as well. We will try our best to address questions as we're going along. I will try and fit them in, ask our guests as we're going. So again, feel free to ask those. We did have a few pre-submitted questions. So future AMAs, when you're signing up, you do have a way of pre-submitting some questions. So if there's something you already know you want to ask, always welcome those pieces of information to help us make sure we're getting our content well for you. Today, I'm going to have on SolArk, and then also we have a developer EPC that we're going to be talking with around integrating these systems. So I'll introduce our guests here in a moment, but excited about this. We are preparing for our education summit in Seattle that happens in October. SolArk is our premier megawatt sponsor, and so they're going to be welcoming everybody on the first morning of that with a similar topic. So we're kind of using this as a preview for that. And in our general session, we'll have them on talking about that as well. So excited for that. I'll give some more information at the tail end of our webinar here on what that looks like and how you can attend. So let's kind of jump forward. For those of you who may not know me, my name is Ryan Mayfield, founder of Mayfield Renewables, and I started the company back in 2007 and started in the industry in '99. And so interestingly enough, when I started in the industry, we were working with almost exclusively batteries, went away from that as the industry evolved, and now we're coming back to it. So it's fun to see kind of full circle, and it's a very different world now than it was then. So excited to have you all here and participating with us on the topic and just kind of seeing how the industry is evolving around this. Mayfield Renewables, we are a consulting engineering firm. So we do project engineering and consulting engineering so around the solar and solar plus storage spaces. Would love to engage with folks if there's projects that you need support on or need support consulting. We do a lot of work with people around helping get their projects across that finish line and helping around codes and standards a lot and some project specific questions. So love to talk with folks and engage with you if that's something we can support. We also do a lot of education and training. That's where my passion lies. That's where a lot of I do. So around this specifically, we do code corners that we put on our YouTube channel. And so we're putting a fair amount of content out there trying to help serve the industry. And as I mentioned, we're doing our second education conference in Seattle. So all of those things we're trying to, further the education, I guess, of within the industry. So we're all, producing and doing a higher level of services and installations. Definitely something that is helpful for all of us, and that's something we put a lot of effort into. So appreciate you tuning in and enjoying the content. All right, so want to introduce our guests. So I'll kind of go through everybody here and appreciate you taking the time. So first off, we're going to introduce Liam O'Brien, Senior Product Manager over at SolArk. Liam's going to help give us some insight around some SolArk specific things, but also just what we're seeing in the industry as a whole. So Liam, would you mind introducing yourself, kind of a little bit of background on who you are and what you're doing at SolArk these days?
Sure. Thanks, Ryan. Yeah, so thanks for having me, guys. So I got my start in the EPC side of the business, mainly doing, sort of I would say higher end residential, a lot of off-grid projects, a lot of, grid connected, but with battery storage. Primarily, most of my business and customers were battery storage. Then I switched over to the manufacturer side, started working at a small storage manufacturer called Fortress Power, and spent some time there building batteries, testing batteries, developing our product line. Then I moved into EV charging for a little bit, sort of got to see that other side of the industry, and then moved over back to SolArk in the sort of solar battery space where I manage our commercial industrial product line, so including our hybrid inverters and also battery storage. And from my perspective, like I see all of those sort of experiences as different slices of the same pie. I really think without batteries, you can't have EVs. Without EVs, you need solar and EVs and batteries all together to really work well. So it's kind of a cohesive package for me.
Awesome. Thanks for joining us. I appreciate your time today. John Ross Cromer, head of training over at SolArk. So for those of you that are going to RE Plus, I'm going to encourage you to stop by SolArk's booth and watch John give his live presentation. It's always fun, entertaining. So John, will you give an introduction, kind of what you're doing at SolArk and kind of what that training looks like?
Right. Yeah, I run training at SolArk, and so a lot of that is telling installers and designers why they should interact with our sales team at the start of a project rather than our support team. But we do a lot of training. We have an on-demand training program called SolArk University that we want all of our installers and designers to run through. If you're a distributor, you're also welcome. So interact with your sales team for that. You can get some NABCEP hours, and that's really, I think, the common thread through everyone here is, our NABCEP background. So I try to collect everything you need to know about SolArk technically within our on-demand SolArk University program. Beyond that, I try to use our webinars to message to the industry the benefits primarily of behind the meter commercial, because I think that's where our growth is going to be for the next few years. So I'm a big advocate of that market, and whether it was with Fortress Power back in the day where I met Eric and Liam, or at SolArk now, that commercial market has just continued to grow and grow, and I think it'll keep growing next year and the year after.
Great. Yeah, thanks for that, and thanks for joining. And then Eric Piekarczyk, president at Synergy Power. I would love to, if you could introduce yourself and tell us a little bit about Synergy and your history. I know that you've been in the industry for a long time, and so kind of where you got your start and where you're sitting today.
Yeah, thank you. I took a free class in solar in 2004 and never had any idea. I was a general contractor, thought I would kind of stay there, and ended up in solar. Been part of several different EPCs. We've definitely focused on designing things around customers, building custom software back in the day because they didn't have a lot of tools. Working with numerous manufacturers, residential, commercial, all sub 1 megawatt projects, and really designed solutions based on markets, based on products available, and seen everything from lead acid to lithium we have today.
Awesome. Great. Well, thanks for joining. I'm going to kind of be tapping into your experience, especially around, implementing some of these projects. We have a project of yours that we're going to look at and be able to get some insight on that. So thanks for joining us today. Really appreciate your time. All right, so let's dive into it. The technical solutions driving microgrid enablement. And I do this a lot when we start talking about microgrids across the board in terms of defining a microgrid, just understanding, trying to start everybody off on the same page. And for me, and I think the way that we as a company approach this definition of a microgrid, it's the fact that we have generation sources. And so on the screen here, you're seeing we have solar, we have maybe a gas generator, we put other there because it could be wind, it could be a fuel cell. We've seen other types of generation sources, and really it doesn't kind of doesn't matter, but the fact of the matter is we have this ability to generate the electricity. And so we also, a key part of this is that storage aspect. And so we are both generating and storing energy on site, and then the ability to serve some set of loads. For this conversation today, we're really talking about kind of these single node or these single applications, single building kind of applications. But really the idea here is that everything is kind of running through this control center. And then a big part of this is the ability to operate in parallel with or independent from the main utility grid. So that's really, when we start talking about microgrids, a big function of this. And we can get into different use cases. We'll talk a little bit about those. Eric's project that we're going to look at next, is one of those types of use cases. And so just kind of trying to set some bounds around what we're talking about, how we're framing this in terms of, what are we talking about with a microgrid? So we talked about this earlier, wanted to open it up to the panel too, just if there's more to add to that and kind of how you see it, or if there's a differentiation that you like to put into play when you're talking about microgrids.
Yeah, Ryan, one of our designers in our network, Kathy Nicholson, has led a conversation on LinkedIn in the last week on this.
Oh, really?
Jeff
Okay, I'll have to
Spees
take a look
has
at that. I know Kathy.
And it's not her definition, but she says there is a Department of Energy definition of a microgrid. Without getting into the exact definition, that the defining feature of it is size is not core to the definition of a microgrid. That it's really a microgrid is defined in its architectural and operational relationship to the main utility grid, independent of what that size is. So a lot of fun and spirited conversation over the size of the microgrid, but it's really that it's any size.
Yeah, no, that makes a lot of sense, and I like to talk about that and say that even residential battery backup system is can be a microgrid, and so if you look at it and you just go by those definitions, the ability to operate in parallel with or independent from, have storage and generation, all of that is, yeah. So yeah, the size definitely doesn't need to come into play in that, in my opinion, as well. So. Great.
Yeah, I think micro throws off a lot of people. They're like, well, it must be small because they put micro in front of it.
Right. Well, if you want to, yeah, we can call the main utility grid the macro grid then, and all of a sudden we don't have a.
I've seen some interesting discussion with Jeff Spies. He's been like, does microgrid seem to fit? It's sort of like, well, if the grid is our baseline, what's below that? So it's like micro and nano. We get into mega, like it gets complicated. But yeah, I think ultimately, what DOE sort of looks at it as is, it's something that, it's a group of devices that can operate independently. That's really, I think, the big defining feature is we're having independence. We don't have grid tied inverters that have to synchronize to something to work. They can operate and form their own grid.
Right.
It's a useful way to think about it.
Which is also interesting because we're going to talk about this, and we're actually in the next slide, we're going to talk about this use case where there's these systems where we have generation and storage, but we are doing grid services and not necessarily operating independent from the grid. So then we start to kind of run into, is that really a microgrid? At this point, we're kind of splitting hairs, I think, a little bit, but definitely something to put out there and to be thinking about.
And not to split hairs further, but Liam, it's Jeff Spies, and he's gotten on me for pronouncing it Jeff Spies. So as my penance, I will pay that message forward.
Yeah,
so,
thank you for pointing that out.
Jeff Spies with plan sets. Yeah.
Those German names are always tricky.
We'll be sure to get Jeff to tune in next time. All right, so microgrid challenges. Let's talk about this. This is one of the big things that folks that are moving into doing microgrids not necessarily are surprised about, but I think the level of complexity can sometimes be overwhelming. And this is coming in, I'm framing this in the sense of moving from our grid tied PV systems into something where we are integrating storage and we are trying to do something more than just push power and push electrons into the meter, run the meter backwards, accumulate kilowatt hours. and see the benefit of, financial benefit that way. So the complexity, there's multiple ways we can look at this. But one of the things that we talked about as we were preparing for this was getting around sales and sizing for specific goals. And this is what you're looking at. This picture is from Synergy Power. So this is one of Eric's projects. So kind of want to kick it off with you, Eric, because during our prep call, I thought you were talking about, sales and involving engineering early and kind of how it's important to kind of marry those two up. So a couple of things, I'd love to have you give us a, overview of the project and kind of how your approach on that internally as a company, kind of that sales and sizing aspect and getting engineering to integrate with that process.
Yeah, great. Would love to talk about it. This site's got several things going on. There's multiple meters. So the meter we're looking at and the solution for this meter especially actually had existing solar installed in about 2008. So we have a system that's approaching the end of its net energy metering. One of the things we wanted to account for in our design. Additionally, we could currently get credit and take this system basically into a non-export mode and be able to capture some of the NEM credits for future winter months like December. It was very undersized, so there wasn't a lot there, but it modeled out to have extra value. We talked a lot to the customer, trying to figure out what the driving factors were between budget, backup if needed, and overall payback scenarios. Oftentimes very, very important to a client of 3-5 years or whatever their targets are. So that was modeled in our software solutions that we work with. We work with different companies depending on the needs, really trying to gather utility information, data, work with the manufacturers to figure out how their products are going to perform, and then size based on those specific goals. And as you see here, there's numerous complexities, different size, different voltages at the utility interconnection versus what the SolArk and the rest of the system was operating at. Non-export, so we're not able to send any excess solar from the new solar to the grid on this system. It has to be stored in those batteries and being self-sufficient as much as possible with that solar. So those are some of the design constraints that we had to plan around and engineer around.
Interesting. So I'm curious, they're metered separately. So you said there's an existing system, it's under a different NEM contract. And so you were able to get a separate NEM contract, and you mentioned multiple meters. So were you completely independent in terms of the metering that you were looking at on this one?
So this system is tied off to the existing meter.
Okay.
There is a separate meter on the back of this large facility here that services a lot of agricultural that does export into the grid.
Okay.
It does have additional storage as well, and solar. So that one operates more how you kind of see it traditionally done. This one, though, because of if we wanted to preserve the net energy metering, we had to go through non-export requirements. There's also additional benefits there for labor costs and things like that, especially here in California, that you can sometimes benefit from. So there's a lot of complexity, and so we designed this system, and the SolArk system is able to handle a lot of this complexity and go into a non-export mode. So the existing solar can export at full power, and it basically is just allowed to send all power all day back to the grid, and then the SolArk system that you're seeing in the pictures here operates and takes care of all site loads as much as possible.
Got it. Awesome. So could you talk a little bit about, so not necessarily this project specifically, but you might be able to use this as an example. But so again, in our when we were prepping for this, you were talking about, bringing engineering in, your engineering team in on the sales side. And as I took it from, you're involved in a lot of that process. So, how are you approaching the customers? A customer comes to you, they want to have storage, how much do they know coming into it? How much do you feel like you have to, this is what it is and it's not possible? And how do you get your engineering team kind of involved with the sales side to make sure you're hitting those targets?
Yeah, thank you for that. So basically what we try to do is we have a person that is ideally going to talk about customer goals, financial constraints or things like that, physical space. And then we have also an in-house engineer, also NABCEP certified from a design perspective. And her goal is to really help meet those design analysis constraints. So whether it's financial or physical space or it's unlimited, do they want backup power, how much? We're going to start running scenarios and try and deliver different solutions, different products that meet those goals. And so in our experience, it does not start with just a salesperson, an outside salesperson that can do those things. Typically, you need somebody that's engineer level that can start running some of these, collecting data, asking those questions, and you really do need somebody else that is more sales focused to be able to help take what the customer is telling and translating that to solutions and making sure that the engineer and the end customer goals are being synced together. And so that's really our salesperson's best perspective, is to be able to help everybody communicate, find solutions. It could also involve finance. It could involve more advanced requirements, such as, TPO, third-party ownerships, or other things like that, cash, tax leases, and things like that. So there's just so many different components to these projects that we really need engineer that's focused on the technical hardware side, and then somebody else is focused on the customer goals.
Yeah, that's definitely a trick, I guess you could say. Unfortunately, we as engineers aren't the greatest of salespeople, and vice versa. So yeah, meshing those two together is important. It's something that we see internally, and this is kind of getting into the planning and product architecture, and pull in SolArk here as well. But on the planning side, I'm curious, I'll ask you one more question here, Eric, but we do a fair amount of feasibility studies. So we are looking at both technical and, you mentioned, the financial aspects of this. And so understanding what those specific goals are for the customer, whether it's, financial, if it's grid services, being able to reduce their overall bill, or if there's an element of resiliency and built into that. So, we're doing a lot of that. We are trying to work with customers. And so I guess I'm just curious on how much, you're looking at that as well, how much you're putting on the front end of that, and expectations to build around for the customer.
Yeah, so backup, I think, is a really good, a lot of times people hear battery or solar these days, and they automatically assume backup is coming with it. They don't care if it's residential or not. Some do have, an experience that there is just no backup power if you have solar only, because maybe they've had solar for years.
Mm-hmm.
So we definitely have seen that happen in the past. However, most people know today that you have to have some type of backup. In commercial, we talk about it very early on, because backing up a commercial facility can be very complex. Oftentimes, the items that they want backed up are, in multiple load centers scattered throughout the property, and can be, very cost prohibitive to move forward and actually create backups. It can be done, but it's more of like, at what cost are you willing to have backup? And does a UPS serve that better? How many hours of backup do we need? Those are questions that, an engineer always wants to know, and a customer never has thought about, almost ever. They just think that they have solar and they have unlimited backup with a small battery. So these are very good planning conversations to have. And site voltage can certainly create additional constraints. We personally see a lot of 240 delta and all these other services that just most manufacturers don't even service. So additional hardware to create backup, all sorts of additional constraints there gets pretty complex.
Oh my, yeah, I didn't even think about the 240 delta problem. And if you're running into probably agricultural areas quite a bit as well, seeing probably a lot of that. So that's, we've seen a few of those, but yeah, that's one of those kind of red flag kind of thing, and all the more reason to get the engineers asking questions early in that process.
Yeah. So that's what that transformer is on the site photo, right, Eric?
240 delta.
Yeah. Yeah.
Nice.
And, you know, one thing I like about this project is you mentioned it's a large facility, and, you know, I'd say would you say this is a smaller system generating a subset of its energy, not the entirety of its energy? So that's, you know, I think there's an element of commercial, there's higher stakes, you know, the better payback comes with more on the line for achieving that payback. Uh, do you see a difference in the payback tolerance for economic only versus backup power systems? Like, I would think economic only are chasing 5 or 6 year paybacks, and, you know, especially if there's, for projects that don't qualify for the tax credit next year, you know, if that goes out to a 8 or 9 year payback, I don't really see that selling without a backup power component. So understanding the right balance of, you know, peak economics and, you know, essential backup, I think is important for the years to come.
Yeah, I see a lot of customers hitting sub 5 year paybacks personally. I'm very interested to see how this is going to change domestic requirements, content requirements, and things like that next year, and which companies are going to step up. Um, you know, we see, my goodness, we see projects oftentimes in the 2 year range with this 10% bonus and some of these other incentives that you can oftentimes get customers to qualify for. So solutions like that oftentimes will pencil very quickly. I find most of my commercial clients are looking at sub 5 years to make a project make sense for them and move forward just because of their business priorities. 7 years, I've certainly seen, we've definitely done nonprofit projects and others that have those constraints, and you know, maybe can only benefit from other third-party ownership type cash flow. And oftentimes, though, there's still savings. Backup can usually, especially with products like this, oftentimes the additional hardware requirements are pretty straightforward, and it can be overall a very small percentage of increase of costs to get backup to a specific critical loads if it's, you know, not super scattered and things like that. So I'm excited. I think technology is going to continue to drive products. I don't think 10-year timelines are something that we see hardly ever. And I think, especially with the cost of energy here in California, which is where I specialize, I just don't think it's something we'll have to deal with too much.
Yeah, and I was also going to point out, did you take advantage of any S-chip incentives or sort of local and state incentives for this project, or
There's
is this just strictly
definitely,
federal?
yeah, there's definitely multiple products like that between state incentives happening. Um, there's, you know, on top of that, if you get domestic content or underserved areas, things like that, brownfields, there's all sorts of extra tax benefits that this client is able to take advantage of.
Yeah, no, I'd say that's another one. It can be a little bit more paperwork, which, you know, just kind of increases the back office load to kind of apply for those and go through the hoops. But in some cases, the incentives can be quite high in California, especially if you're doing agricultural applications, because a lot of those, you know, the sort of territory of agriculture and I forget what they call them, but sort of like, you know, distressed areas or whatnot, or certainly fire danger areas. You know, all over Napa, you've got all these wineries that have large loads, and we've done several projects. We did a winery up in Harrodsburg that I went and visited, and they get secure power shutoffs. So that's another case for, you know, lowering energy costs when the grid is up, and then providing backup power for their operations, so they can, you know, keep the wine flowing even if the power goes up. You know, it's multiple pronged, and then you can kind of layer on some additional incentives for that. But yeah, and it's not just California. I mean, you know, I'm originally from the East Coast, and Massachusetts, New York State, both have similarly increasing, you know, energy costs and also relatively good rebate programs. I think New York and Massachusetts definitely lead the way in terms of compensation for solar projects. And there's different adders you can get for those same things like brownfields and other, you know, residential or ground mount versus rooftop and that kind of thing.
Yeah.
Excellent. I'm gonna keep an eye on the clock here a little bit. And I want to make sure we talk about the controls, this dispatch and programming. That was a big one that we talked about in our prep, and we actually got a couple questions about it. So probably gonna, Liam and John talk to you a little bit, have you kind of talk about this a bit. So in terms of the controls, this is definitely what we see is a big part of the project, maybe one of the not necessarily the hardest, but it's a challenge, and it's one of those that I think people maybe don't think about early enough when getting into the project. And so we'd love to hear you kind of talk about, the controls that are part of the product offering that you have. And then also there's definitely the ability of bringing in third-party controls. And so would love to kind of ask the question of, from your perspective, when's the right time to ask those questions? Or, probably the right time to ask questions is early and often is probably the answer to that. But I guess what are some of those questions, and what should people be looking at in terms of, oh, I need to think about my controls a little bit more beyond what, is out of the box kind of thing?
Yeah, no, and I really think anybody who's been in the military might be familiar with the 7 Ps. Proper planning and preparation prevents poor performance. And so proper planning and preparation is the key part there, where you've got to ask questions in advance. You talk about things like the 240 Delta. We've unfortunately had some installers where, they kind of just went down the road and, did their site walkthrough, did a basic, take some photos, take some notes, whatever, start installing the project. And then they find out, oh, hey, we have this weird service. We have a 480 volt corner grounded, or we have a 240 Delta, or we have a high leg Delta. And so that site walkthrough is really important. That's like the earliest you can do. But then also, as you start thinking about the complexity of the system, as you had your earlier slide, there's lots of different sources all coming together: batteries, solar, fuel cells, generators, et cetera, to make the system work together. When you should bring in edge controls and when you should kind of, start thinking about more sophistication, the lawyer answer is it depends. With every project, there's always going to be sort of variables. I would also say, as you look at C&I, commercial and industrial, a lot of the commercial projects are a little bit simpler. I say little because we've had some really complicated ones, but commercial can tend to be simpler if you've got, one of these HVR cabinets and an inverter powering something like a dentist office, or, some building in a mall or something like that. That might be relatively simple. You might just be doing time of use. There might not even be a peak shaving rate for that customer based on their utility rate plan. And so in that case, the built-in controller, I'd say our SolArk inverter more or less has sort of EMS light built into it. So it can do a lot of things built in. You can have time of use schedules. Obviously it supports, automatic transfer to backup with our, grid and load port. We also have a generator port that allows some other interesting applications. But, I'd really say as you start to move up in size, that's sort of a good indicator that maybe I should bring in a professional or start thinking about controls. So, as you get to that 1 MWh plus mark, that's kind of a good time to start thinking, hey, is this getting a bit large and complex? Also, the more components you have, if you just have a SolArk, a battery, and some rooftop solar, that's pretty straightforward in most cases. But, as you start adding in maybe a genset, which, again, that's another one where it depends, because we support 2-wire gen start. So if you have a relatively simple, smaller generator, you may not need that. We already have sort of a generator controller. If you get into, a large industrial facility and they have a 300 kW Kohler that takes up, a quarter of the parking lot and has Modbus controls, then you need to have some kind of an EMS or some kind of control system to coordinate what the inverter is doing. Also, if you have separate transfer switches upstream of the inverter, that's another complicated use case that we've seen. So I think as you start to layer on size of system and complexity, breadth of system, more components that have to interact together and work flawlessly, that's where you'd really want to bring in somebody. Also, if you're trying to kind of wring out that last maybe 10 to 20% of economic savings, again, as we talk about, microgrid could be, I want to go off grid or have backup power, but it could also mean I want to use my battery intelligently when I am connected to the grid. And if you do that, I think, 80% of the savings you could probably get with a basic EMS, and that might be good enough. If you're trying to wring out that last little bit out of the towel, working with a company like Energy Toolbase could be a good option. They have a really good economic modeling engine and a controller that goes on site and ensures that actually, the system performs. Whereas if you're trying to do more complicated controls, somebody like New Sun Road might be a good option. They're another one of our partners with SolArk, that provide sort of more microgrid and off-grid and coordination between different pieces of equipment. And then obviously you have Agito was a major player in the space. Now that Generac has bought them, it's changed their focus a little bit, but they still are actually working on projects with us with the Agito controller, and that was another big microgrid space. So it's
we do a lot with. Yeah, we do a fair amount with the Agito, and there are definitely multiple controllers out there, and probably more than we can mention in any one. But I think the complexity part of it, and just as you're adding those other resources, and that grid interaction is a really big part of it.
And I'd also just say it's sort of a security system almost for a system. So you could put one on there and not truly need it from a functionality perspective, but it might be kind of a good peace of mind to have sort of enhanced diagnostics or reporting or economic reporting. I know ATB has some really good integrations where you can both monitor the system and then compare it to the original economic model that you produced, and then you can also compare. You can basically sort of do a bill match. So they will say, we think your bill should be this, and then you can compare that to the actual bill to see if there's a discrepancy. Because believe it or not, utilities are actually really bad at record keeping. And so they'll not pay you what you're owed. And then of course they'll argue that they're right because they're the utility. So, it's always good to double check the math and have some kind of a security system in the background that's watching your system and seeing how it's performing.
Yeah, there's a lot that SolArk can do out of the box. For commercial time of use, it has a seasonal time of use controller. Even when you get into California battery incentive requirements that require solar charging and not grid charging, the SolArk can do that. It can also do demand plus time of use overlaid, but the more complex value you want to get out of the SolArk settings, the more you have to prepare to program those settings, and integrating with a third-party controls company, you don't have to worry about that. So there is a value add. One thing I would say is while SolArk for some time has worked with private integrators like Energy Toolbase, we haven't really well documented that publicly. And so you really have to kind of lean into the integrator providing it and kind of validate them that way. Mainly because it's just we give out our Modbus map through the sales team under NDA and kind of regulate it that way. So there's a little bit of tire kicking you have to do when selecting. I recommend it for generators whenever it's more than a 2-wire start. And then also when you get into peak shaving, what I think about is on a utility scale system, the controller is not just a specialty part, but it's a specialty contractor that shows up on site to actually program in the battery controls and the energy control schemes on site. So where does that come to the point where just a standard installer can do that instead? And there's some bandwidth in like mid-sized commercial where you start to absolutely want to add on third-party control software, and then by the time you get to utility scale projects, it becomes somewhat mandatory. So,
okay, there's a lot. I feel like we could spend the whole hour on this slide, so I'm going to keep us moving along. I do have more to say, but I want to make sure that we give time for the other stuff because I want to make sure we cover it. There's also 2 questions on here that I wanted to address because I think they're timely on this, and so I think they're relatively easy as well. Patrick was asking about time of use on commercial businesses. Eric, that's probably something that off the top of your head. I'm presuming that there are time of use on commercial. Patrick was saying that he's seen it on resi, but was asking if that also exists at commercial.
Yeah, absolutely. California has all time of use rates now.
Okay. That's what I thought. I just wanted to make sure that I wasn't saying something out of turn. And then William was asking the question, how common are jobs where customers sell the energy storage yield back to the utility at times of peak usage versus peak demand shaving projects? So are you seeing energy arbitrage, selling the energy versus those peak demand charges being a driving force one way or the other on the projects.
Yeah, and I saw several questions that kind of asked if we are curtailing and why we're curtailing along that same note. And so, yeah, we're curtailing. Oftentimes, there's just more value in using the old interconnection values that were originally given. As far as the demands and those rates, oftentimes saving the battery for the peak rates is very good, can create a lot of value. And that's when the controllers can come in. SolArk has a basic controller built in their product, so you can start off with whatever your product may have and go from there. But certainly solar in California at noon in April is pretty much valueless now to the grid, and you will get nothing for it. So you do have to realize that based on your utility and what they may give, you may be getting nothing for a significant amount of annual performance that has no value to the customer or the utility.
So yeah, getting into that planning and that understanding the economics.
Yeah, I'd say the arbitrage value is basically selling the energy to yourself. Like, you don't actually want to sell it to the utility. They won't give you very much for it. It's more about arbitraging to self-consume. So storing your solar power and shifting it to that later time.
I like that. Sell it to yourself.
Yeah.
All right.
For a good price.
For a good price. All right. I want to move us along. We do have a few more slides, and like I said, maybe we'll start making these 2 hours long or something, see if we can keep people's attention. Evolution of technical solutions. So really just kind of want to open this up, looking at how the products have changed. We have a list of things here, and I guess just from the perspective, I'll kick it off, maybe Liam, to you and John here, just talking about, what's that look like in terms of the evolution of the solutions, and how, I guess, specifically is SolArk approaching that in terms of some of these major bullet points that we have.
Yeah, so I think in terms of product, one of the big things that we came out with our L3 series batteries and our 3060K high voltage inverters back at basically the end of 2023 and into 2024. There was very few other products comparable on the market at the time, and I really think what was different for us was, I went to Intersolar that year, and we're pitching the product and showing it off to installers. Most of what was out there was grid scale, so containers, 20-foot, 40-foot, high cube, 5 megawatt hour, 2 megawatt hour grid scale systems, and trying to shoehorn those into, maybe it would work for an industrial building, but for a commercial building, if I have a fast food chain, I can't really have a container taking up my parking lot. It just doesn't work for that customer. So we really kind of came out with this third middle category that's not residential. It's bigger than that, and it's not utility scale. It's C&I, and really having a dedicated product line, I think, has just sort of opened up this whole market for installers like Eric and many others that buy our product, where it's purpose built for that application. It's sort of the right size. You look at here, the L3 HVR. This is our outdoor battery cabinet. It's the size of like a larger refrigerator. That's a lot more reasonable to sort of tuck into different spaces around a building. You could put that, in some cases we've had people put it in an existing spot where there was already like sort of a concrete, bunker for a generator. They took the generator out and put that in there, or reused an existing pad. So it's much more modular, and also the inverter and the battery are separate. So we kind of decouple the architecture. So you can have an indoor battery, outdoor battery, 208 inverter, 480 inverter. You got lots of flexibility. You can stack things. So it's not the sort of monolithic thing that you need to, sit down, spend 2 weeks configuring, order it, wait 6 months to receive it at the site. It's sort of like you can just call up and say, hey, I need 5 of these and 5 of those, and get it shipped to you within 2 weeks. It's much more readily available.
Yeah. Nice. Yeah, and folks that know me know that I'm not going to let an hour go by without at least mentioning codes and standards. And so, that those are constantly evolving as well. We're seeing changes in 9540A and other standards coming out. One of the interesting things too, just to kind of throw it out there, IEC got involved with talking to some folks about bringing some IEC standards specifically around microgrids. So there's a vetting process looking at, are we going to adopt those in the US, and kind of go through that process. So there's definitely a lot of work going on, and in that world. And of course, codes and standards being the process that they're always behind the times, behind the technology, just because technology is not going to wait for codes and standards. In a lot of ways, it's the technology is driving what we put in codes and standards. So it's very interesting dynamic from my perspective as well.
Yeah, I would say on that topic, it's one of those things where we as a manufacturer, we've found out very quickly that if you're not at the table, you're on the menu. So you have to be involved and engaged, especially when you look at fire codes. If you actually look at this image, this is the inside of our HVR. We have, smoke and CO2 and fire detection systems. We also have a fire suppression system built in. We probably have more than arguably we would need on a system this scale. But the problem is, because we sort of, as you say, codes are slow to catch up, we've created this middle product category. Most of the inspectors are like, well, the residential standards are too small, those don't apply to you. So the next best thing is utility scale fire code and standards, and we're going to apply what applies to a multi-megawatt hour system. We're going to apply that to 60 kilowatt hours of battery, which is about the same size as a mid-range EV that gets parked in a garage across America. I have a lot of opinions on that. I don't want to start a flame war. We could probably have an hour discussion on that, but yeah, there's lots of things. So we've tried to bake safety into the product to kind of, be preemptive in that. But it's definitely, that's a major consideration when you're selecting equipment is what codes and standards does it meet? Both product standards like 9540 and then also installation standards. Like, can you install it in a code compliant way? In California, we have CFC, which adopts NFPA 855. And so there's lots of installation details that can trip you up.
Absolutely. Yeah, and this was a picture that Eric gave it to us, and so I liked it a lot, and that's why we're showing those the fire safety stuff. That was exactly what caught my eye. I was like, we need to use this photo because of exactly that reason.
It's a really good photo.
It is. Yeah, whoever took that, great job.
These are things you have to show inspectors to help them believe that this is real.
Yeah,
exactly. Look, I'm not lying. Yeah.
All right, I want to move on into this next slide and give John and Liam a little bit more time to talk about kind of those product solutions, and then the slide after this, it kind of gets into the integration into our electrical system. So I know, John, you really wanted to talk about load side, line side connection. So I want to make sure we leave some time for both of these. So yeah, Liam, you already kind of touched a little bit about some of the products, but yeah, I guess you want to give us a little bit more on kind of where these sit and how they're fitting into these commercial applications.
Sure. So I'll start from right to left, actually, because that'll make a little bit more sense. But so really the nexus of energy flows is the inverter. And so we have two models. It's very easy to figure out which one you need. We have a 60K and a 30K. Basically, the question you need to ask is, what is the service voltage? Although, as we touched on, that could be a little complicated. But in most cases, for most sites, if you have a 12208Y, you're going to buy a 30K inverter, and those stack up to 300 kW AC output in parallel. And then if you have a 480 volt, 277Y or a 480 volt Delta, you can stack those up to 600 kW AC. And again, that's all fully modular. So I know the inverter is shown mounted to the HVR cabinet in that second item, but you can actually mount it on the cabinet on either side. You can mount it externally of that. It's a separate part that you buy separately, so you have a lot of flexibility and configuration. We actually have a lot of people who will buy maybe 2 or 3 inverters paired with a battery, and then they'll actually buy additional 30K inverters, especially to have a 30 kW string inverter. So they won't even connect it to a battery. It's just a string inverter, which is another use case for our products. So, that gives you a lot of flexibility. The HVR batteries are our outdoor cabinet. So that includes, HVAC, fire suppression, the whole 9 yards. You can stick it out. It's got all of its life support systems to work outdoors in pretty harsh conditions. We go down to -20°C. So we've got some stuff up in colder climates. The limitation there is we do have some scale limitations. So we only go up to about 2 megawatt hours of total storage. If you have very cold applications, so we have some up in like way northern Canada, can't put anything outdoors, you got to put it inside in sort of a basement bunker. So the indoor batteries are great because you remove all the expensive enclosure and HVAC systems, and you just rely on having a conditioned space. So that's our HV series. Again, both of these work with the 208 or 480 volt inverters. So those are another great option. We've also started selling a bundle with our inverter and the AES 210, which is Discover Energy. That's their high voltage commercial solution. So that's sort of equivalent to about 4 of our HVRs in a single cabinet. It's 210 kilowatt hours of DC storage. And so you can basically pair that with one of our 60K inverters, and get a really attractive, you can either do a 2-hour or 4-hour configuration, depending on, you can either do 160K or 260Ks. And so that's great if you want to have, let's say you would use 4 HVRs. It's just way more space efficient to buy that single bigger cabinet and stick that outside. Also, they have a really competitive price point per kilowatt hour. So if you're trying to compete on sort of larger projects where there's more storage, budget ROI tends to be much more important. And so they've got some really industry leading price points. They also have things like fire suppression and actually liquid cooling as well. The HVR is air cooled. So it's, just really robust product at a really good price.
Interesting. So the product there, the AES on the left, that's really just battery cabinet with BMS integrated, HVAC and things, basically for the batteries themselves. Is that a list? That's basically listed 9540 as a DC system. Is that how they went about that?
Yeah, so Discover is kind of one of the leaders in that space, where pretty much all their products, if you look at the rack mount series for low voltage residential, those are DC listed ESS. So
Okay.
getting into sort of the nitty gritty, there's multiple editions of 9540. And so
Right.
edition 3 allows for dedicated DC ESS. You can just list the battery as a 9540 battery. And then flexibilities, you can pair it with any 1741 inverter. Obviously, there's got to be some compatibility because the BMS has to speak to our inverter, which we've gone through with Discover. But it's just a lot more flexible because then it works with either of our inverters without a lot of fuss. And again, still all UL listed. It's got all the right certs, but more flexible.
Yeah, I brought it up just because the question came up just yesterday about that exact thing about the DC listed 9540. And so I think it's something that people still aren't necessarily always aware of the DC versus AC listing on, and the ability to have both of those on there. So
yeah,
cool.
the
Thanks for
that
that.
It's that cell size on the AES 210 with the over 300 amp hours. That drives down the pricing per kilowatt hour of the battery. So that's and that is also reshaping our capabilities in residential as well. Because there's a right way to make a battery less expensive, and that's larger cell format. And then there's other ways to make a battery less expensive. We see Discover using these higher ampacity cells in both mid-sized to utility scale commercial, and as well as residential. So that's an exciting new way that prices come down. Which will help, the residential market lacking access to tax credit next year.
Yeah, these are really utility cells that they've taken a utility cell that would go in one of those megawatt hour, systems, and then they've redesigned that, repackaged it to suit the needs of a more commercial industrial size factor, but retaining that low cost per kilowatt hour.
Nice. All right, John, I want to give you a couple minutes here and make sure that we talk about around the product solutions and kind of this simplifying the installation. So we talked a lot about this in our prep, and talking about load side versus line side being a big part of it, and these minimal or zero export cases. So can you kind of talk to us about that solution, that product solution, and how that fits in with this simplifying the installation?
Yeah, so the SolArk installer network over the last few years has gone away from essential load backup and into whole building backup, like with residential, kind of going from our original product line with the 8K and the 12K to whole home backup systems with the 15K. But we have to kind of go back to our roots now that we've grown into commercial, because a very unique value of SolArk that you don't get with larger ESS systems is the ability of a load side interconnection. So your interconnection point can be on the load side of a commercial service, and as what the graphic shows, you're only backing up 1 or 2 sub panels tied into the load port on the inverter and maybe tied into the gen port on the inverter. So this is how you can do a small system on a large site and deliver peak energy arbitrage and also deliver essential backup. So this is the right system that is bite size and accomplishable for residential installers seeking to get into commercial. But this is also a modular system that a commercial installer who's very comfortable doing these projects can just go and sell up and down the street in these markets where you have, high energy rates or high demand charges. So, in solar, the mindset was like cover the entire roof with solar panels. With batteries, you have the advantage of a small system still having a very big payback by focusing just on peak energy deployment. So load side interconnections for commercial is a very valid strategy, and I just wanted to raise a little awareness on that.
Yeah, no, I appreciate that. And kind of in this image, we're showing those essential loads versus sheddable loads. And so this gets into, controlling, doing some PCS and things like that, which I know, is a big topic and discussion in of itself that we've had before. So I think approaching it that way will really help on the installation side. What we're seeing on the engineering when you're doing a whole system backup, or sometimes not even a whole system backup, but just having to add those extra controls and those extra grid protection features, contactors or motorized breakers to do that isolation just adds to the complexity. So, I think this approach really kind of helps lessen that pain in a lot of ways. And so I'm glad to see that approach, or that approach from SolArk on that.
Yeah. We do have an audience member asking about meeting FEOC requirements for the ITC. And, my number one recommendation is to start your project this year. And thankfully for the SolArk product range, that means you can put a 5% down payment. But, be prepared for all of your 2026 pipeline to put that 5% down payment down, mid-December, so that you have the pipeline going. So, that might mean polishing up on some of our construction finance partners who do provide, short-term loans for project material to, help you reserve that pipeline. But you better plan on your sales cycle having a signature and a deposit sometime in December.
Yeah, I'm curious. I'm going to put you, Eric, on the spot a little bit here. Just, I guess, is that with that announcement, how has that impacted you? Just kind of how in your business, and I think you can speak to a lot of folks out there in the audience too.
Yeah. So CalSTA is a great resource in this space, because obviously my business is not to monitor all of the new requirements coming up. They help us a lot with that. So CalSTA in California, SIA obviously does a lot in this space as well. Consult others. My understanding, the way we're approaching it, I can share that, is we are not only getting a deposit down, but my understanding is you have physical construction. So that might be meaning pouring concrete pads. You might have to separate some of this work out for the permitting purposes to be able to do some of it and just get something going. But I believe you have to have some type of actual physical, bolt something to the wall, land some concrete or something like that to get that and secure that. Materials and all of that, safe harbor paperwork can be filed, continuous work on that, and you could have years open, from my understanding, to
Well, the SolArk comes with a wall mount bracket, and that's also you could buy those controllers ahead of time and stick them on site ahead of the rest of the
exactly.
Yeah.
I'd also
I'll just throw out there that, that definitely not the intention that, we kind of went a little bit on the FIOC stuff and everything, definitely not our intention. And so consult, obviously get the cover my butt kind of thing, consult your, attorney or attorneys and accountants and all that to make sure they make sure you're doing it right. So definitely not giving people that necessarily solid advice. So we're getting to the top of the hour. So I do want to call out again that, we are doing our education summit, SolArk being our lead sponsor. I think we've convinced both John and Liam to show up there, and we're trying to get Eric to show up as well. So we'll see if we can get everybody there in Seattle. Would love to see folks from the audience there. This is just kind of a preview of what we're talking about. And we'll have a lot of, we'll have 3 different tracks on microgrids, codes and standards, and being able to just talk about, the classes that we do around PV systems and storage. So would love to have folks join us there. And then finally, here's our contact info. Always love to hear from people. If we weren't able to get, looks like we got through most of the questions. If you have further questions, ideas on other content or things like that that you want to see, would love to hear from you. You can always reach out directly to me. And I do want to thank Eric, John, and Liam for joining. It's been a pleasure. It's an hour that's flown by yet again. So thank you guys. Appreciate your time and appreciate everybody out in the audience.
Yeah, appreciate you
Good luck.
having us, Ryan.
Thanks for having us.